Alright, welcome to today's class. In today's class, I will show you how to prove the divisibility and multiple of an equation using mathematical induction. But before we proceed, if you've not subscribed to this channel, please subscribe now and also like this video. In the course of this tutorial, if you have a question, you can kindly leave your question in the comment section of this video and I will give you an answer. All right, let's look at the question. It says, show that 8 raised to the power n minus 3 raised to the power n is divisible by 5 for all possible integer n. So we are asked to show that 8 raised to the power n minus 3 raised to the power n is divisible by 5. All right, when you say something is divisible, what do you mean? Let's say we have 12. When you say 12 is divisible by 2, 12 is divisible by 2. If you divide 12 by 2, it will give you 6. 12 is divisible by 2. That means 2 will divide 12 and it would give you a whole number without a remainder. I will repeat. When you say 12 is divisible by 2, that tells you that 2 will divide 12 and your result will be a whole number without a remainder. So 12 divided by 2 is 6. 6 is a whole number and there is no remainder. All right, let's look at multiple. For multiple, when you say something is a multiple of another, let's consider 12 again. When you say 12 is a multiple of 2, what do you mean? You mean that 2 should be able to multiply another whole number to give you 12. So 2 multiplied by 6 will give you 12. Therefore, 12 is a multiple of what? 2. Or 12 is a multiple of 6. Alright, for the question given, we have that 8 raised to the power n minus 3 raised to the power n. And we are asked to use mathematical induction to confirm if this equation is divisible by what? By 5. So the first step here, we have 3 major steps in solving this problem. 3 major steps. The first step is the basic step. So we have the basic what? Basic step. And the basic step, n is equal to 1. For basic step, n is equal to 1. So wherever you see n, you kindly substitute 1. So we have here 8 raised to the power 1 minus 3 raised to the power what? 1. 8 raised to the power 1 is 8 minus 3 raised to the power 1 is 3. So 8 minus 3 is equal to what? 5. So that's the answer for the basic step. Now, 5 divided by 5 is 1. So 5 can be divided by 5. So for basic, 8 raised to the power n minus 3 raised to the power n is divisible by 5. Alright, the next step is the inductive hypothesis. So we have inductive hypothesis. For the inductive hypothesis, n is equal to k. So wherever you see n, you simply substitute k. The equation given is 8 raised to the power n minus 3 raised to the power n. So if we substitute k here, we would have 8 raised to the power k minus 3 raised to the power k. Now, for this inductive hypothesis, take note of this. Remember, we are told that this equation should be divisible by 5. This equation should be divisible by 5. So you kindly divide by 5. So if you divide it by 5, it would give you an answer. And that answer you don't know yet. So let's say the answer is L. If you divide this equation by 5, it should give you an answer. And we don't know the answer yet. So let's assume that the answer is L. Where L is an unknown integer. So where L is an unknown integer, we are yet to know the value of L. So from the equation, from this equation now, we can cross multiply. So if we cross multiply, we will have that 8 raised to the power k minus 3 raised to the power k is equal to 5 multiplied by L. Okay, at this point, let's make 8k the subject formula. So if we make 8k the subject formula, we would have 8k is equal to, we have 5L, and then negative 3k moves over to the right hand side, it becomes positive 3k. Alright, let's call this equation 1. Alright, the next step is inductive step. Inductive step. That's the next step. And for inductive step, n is equal to k plus 1. N is equal to k plus 1. Now remember that the equation given is 8 raised to the power n minus 3 raised to the power n. So wherever we see n, we substitute k plus 1. So here we have 8 raised to the power k plus 1 minus 3 raised to the power k plus 1. So here we would apply the law of indices. If you don't know how to apply the laws of indices, or you don't understand indices in full, kindly check the description of this video and you will see a link to our tutorial on indices and the laws of indices. So if you apply the law of indices here, you will have 8 raised to the power 1 multiplied by 8 raised to the power k, and then minus 3 raised to the power 1 multiplied by 3 raised to the power k. Alright, at this point, we are going to substitute the value of 8 raised to the power k. Let's check the previous calculation. Remember that 8 raised to the power k is equal to 5L minus 3k, which we called equation 1. So if we substitute 5L plus 3k for 8 raised to the power k, we would have 8 open brackets 5L plus 3k, 3 raised to the power k rather, and then minus 3 multiplied by 3 raised to the power k. So we can now simplify further. 8 multiplied by 5L gives us 40L plus 8 multiplied by 3 raised to the power k gives us, so we'll write it this way, 8 multiplied by 3 raised to the power k, close the bracket, and then we have minus 3 open brackets 3 raised to the power k. All right. So at this point, 8, 3 will be subtracted from 8 because they are both multiplying the same base. 8 is multiplying 3 raised to the power k, and then 3 is also multiplying 3 raised to the power k. So we can simply say that 8 minus 3, and 8 minus 3 is 5. So 5 will multiply one of the base, or one of the numbers given there. So we have 40L plus 5, open bracket, 3 raised to the power k. All right. All right, so at this point, we are going to open the bracket again. So we have 40L plus 5 multiplied by 3 raised to the power k is 15 raised to the power k. All right, at this point, you can choose to leave your answer like this. Why? Remember, we are asked to find if the equation given is divisible by 5. So 40L can be divided by 5, and it would give you a whole number without remainder. 15 raised to the power k can also be divided by 5, and it would give you a whole number without a remainder. So therefore, the equation given is divisible by 5. So let's just simplify this. So we bring out 5 here. Open bracket, 5 into 40, or 40 divided by 5 is what? It is 8. So we attach L, plus 15 divided by 5 is what? Is 3. So 3 raised to the power k. So this is our final answer. All right, let's take another example. If we have 8 raised to the power n plus 6, and we are asked to check if 8 raised to the power n plus 6 is a multiple of 7, how do we go about it? Now we are looking for multiple, not divisible. So we have 3 major steps. The first step is called the basic step. Let's write it down. Multiple of what? Of 7. We are asked to check if 8 raised to the power n plus 6 raised to the power n is a multiple of 7. So for the basic step, we have the basic step. For the basic step, n is equal to 1. So we have n is equal to what? 1. So wherever we see n, we substitute 1 rather. So we have 8 raised to the power n plus 6. 8 raised to the power what? 1 plus 6. 8 raised to the power 1 is 8. So 8 plus 6 is what? It is 14. Is 14 a multiple of 7? Yes, because 7 multiplied by 2 would give you what? 14. Therefore, 14 is a multiple of 7. All right, the next step is the inductive hypothesis. Inductive hypothesis. For the inductive hypothesis, n is equal to k. So wherever we see n, we substitute k. So we have that 8 raised to the power n plus 6. So if we substitute k here, we would have 8 raised to the power k plus 6. Now, we are asked to check if the equation is a multiple of what? 7. So that's to say 7 will multiply a number to give us 8 raised to the power k plus 6. So let's say 7 multiply m. Now, we don't know the value of m. We don't know the value of m. So therefore, m is an unknown integer. N is an unknown integer. All right, from the equation, let's make 8 raised to the power k the subject formula. So we have that 8 raised to the power k is equal to, if positive 6 move over to the right hand side, it becomes negative 6. So we have 7m minus 6. So let's call this equation 1. All right, the next step is known as the inductive step. The inductive step. For inductive step, n is equal to k plus 1. The equation given is 8 raised to the power n plus 6. So if we substitute k plus 1, we would have 8 raised to the power k plus 1 and then plus 6. At this point, we are going to apply the law of indices. 8 raised to the power k plus 1 can also be written as 8 raised to the power 1 multiplied by 8 raised to the power k according to indices, and then plus 6. So at this point, we are going to substitute the value of 8 raised to the power k. Remember, 8 raised to the power k is equal to 7m minus 6. So if we substitute it here, we would have 8 open bracket 7m minus what? 6. And then plus 6. So we can now open the bracket. So 8 multiplied by 7m gives us 56m. 8 multiplied by negative 6 gives us negative 48. And then plus 6. So we have here 56m. Negative 48 plus 6 gives us negative 42. So we can now factorize. In the question, we are asked to find if the equation given is a multiple of 7. So factorizing, you will bring out 7 and then open bracket. 56, can 56 be divided by 7? Yes. 56 divided by 7 gives us 8, and then m minus 42 divided by 7 gives us 6. So at this point, we can say that the equation given, which is 8 raised to the power n plus 6, is a multiple of what? Is a multiple of 7. Is a multiple of what? 7. Because 7 multiplied by 8m would give you 56. 56m. And then 7 multiplied by negative 6 will give you 42. So this is our final answer.